Hi Eric, myself Ansha Kala. So today, today my project for Fogandedge computing module is simulation of low latency task offloading framework in vehicle edge computing using physiologic and PSO. So PSO means is a particle sum optimization. So here this work is based on the research paper that I got from ACM in 2023, and it is implemented here. It is implemented entirely on software simulation on AWS EC2. So as we know, again, our edge computing brings computation closer to data sources. So here we are using vehicle edge computing, which extends this concept to vehicles, which enabling them to share data with each other. I mean, computation in real time. That's what is done in our project. So there are lots of challenges here, which include the mobility, variable wireless link qualities, heterogeneous resources. And here in this project, we have to implement a trust-aware, low latency task offloading strategies, which address these challenges that we are doing here. So this is the research paper, the low latency vehicle. So basically, this is the research paper, which is from ACM and is written by the author of UVA and Gishan and I got it's a peer reviewed one from ACM. And so basically, we can go to our system design. So what we are doing in this project, it is mentioned in the system design. So here, our workflow starts by generating a task vehicle and surrounded by multiple neighbors. So these neighbors are in the distance of 300 meters and they are considered as offloading. And then I'm generating a physiologic model which evaluates each neighbor and sorry, okay, which evaluates each model and assign a performance score. So those score is below zero point 0.5, those vehicles are selected. So this PSO, this is particle sum optimization, which determines how to split the task among the vehicles, and thus we can reduce the total delay. And after that, we are calculating delay and success rate calculation. So the main tools that we are using is the Python and SKFUC, PySwarm, NumPy, Matplotlib, and AWS EC2. So this is the overall diagram of what we are doing. This is architectural diagram for our project. So this is a simulation parameter. So we are total we are generating 21 vehicles, and which is in the communication rate of 300 meter. And the task size is ranged from 2 to 10 MB, and CPU cycles is 100 and the bandwidth is 27 MB per second, and the maximum delay is 6 seconds, and the frequency threshold is 0.5, PSO iteration is 15. These are considered while simulating the parameters. So coming to the implementation, so what I did, I created a vehicle.py file, which is uh, defines the vehicle attributes, and in Physio selector py, what I'm doing is I'm implementing the physiologic here and PSO optimizer in that file. I am including the PSO algorithm as well, and the simulator.py, the main simulation. Which ties all the files together, all the py files together, which will do the simulation, calculating metrics and generating plots. And in the output, including here, I'm plotting two graphs, which is from delay versus task size and success rate versus task size as well. So this is I mean in the sense of fog and edge computer, this is what I had done. So in the big data, what I'm doing, I simulated in that place, I did the simulated task case ranging from 2 to 10 MB, which is coming from the big data. And task offloading, for that I created two Python files called simulate.py and ps optimizer.py, which will do the task offloading. And for the wireless communication, we have created vehicles in a random position, and I'm checking the proximity to simulate the V2V, the vehicle to vehicle communication range, which mimics the wireless simulation. And for the Fogandedge processing model, we are simulating a task vehicle which offloading to the neighbor vehicles. And this model distributed the Fogandedge environment, and the latency measurement is done over here, and it is plotted in the graph. So this is the result that we got. So the delay plot shows the total delay, and which increases as the task size grows. This is expected because the larger task requires more transmission and processing time, of course. And the success rate plot, that is here. The success rate plot is here. So in the success rate plot, we are doing is the reliability of the 2 MB and 4 MB task, but it drops sharply after the 8 MB to 10 MB task, and which is exceeded in the 6-second millimeters often. So that's what I've done. I will show what I've done in my. So this is the EC2 instance that I created. This is the instance here. This Forganet is the instance that I created, and I have connected locally over here. So this is the local connection here. And in CD offloading, I have created the VC selected.py, PSO selected power requirement and simulation. So if I run the simulate.py, the simulation offloading and everything is happening over here. And finally, the data, the output are stored over here in local machine. So here you can see the success rate delay plot and success rate plot is all spotlight. So that's what I am doing here. And in conclusion, what I can say, so I have implemented the physiologic plus offload PEOC approach, as well as the offloading in BEC, so which achieve the low delay and high success rate for small medium workloads. So that's what I'm doing here, and this is my fog and computing project, and that's it. Thank you.